So do you see how across the top here, it actually gives you the steps? Write separate radicals if necessary, simplify each radical, and then write the product. Remember that there's going to be something we can take out and sometimes something we leave inside if that last part cannot be simplified. So let's go check out some of these and see how it looks. So if it's a perfect square, when we square root it, we can take the whole thing out. So 121, we know that that's 11 times 11. And x squared, we know that that's x times x. So this happens to be a perfect square. If you'd like to apply the rule, you could think of it as the square root of 121, and then separately the square root of x squared. Remember that the root cancels the power. So square root of 121 is 11. Square root of x squared is just x. And we learned in the video today that actually there are two options sometimes for this. There's a plus or minus. But when there's a variable in this equation, in this expression, I'm just going to leave the answer without the plus or minus since we don't know what x is. So we're just going to say 11x right now as our result. Okay, let's go do the same thing for the next one. Square root of 81, square root of h to the 6th. Above here it shows us stretching that out if necessary, meaning h to the 6th could be like saying h squared, h squared, h squared, because the square root of h squared is just h. Square root of h squared is just h. Square root of h squared is just h. Square root of 81 is 9. Final result is 9h to the 3rd. Square root of 16, that's just 4. Square root of c to the 4th. What if I broke it up into square root of c squared, square root of c squared? Final result. Square root of 100, square root of p squared, square root of q squared. Square root of 25, square root of d squared, square root of d squared. See how I'm splitting that up? Oops, I'm going to need some space here. Hang on. Okay, so that gives me 5 d, d, e, 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 or final result of 5d squared e to the 4th. Square root of 49. Let's break down that x to the 10th. And that gives us 7. 1, 2, 3, 4, 5. 1, 2, 3. So what if you don't want to do all this stretching out, right? Could you just look at x to the 10th and take the index of 2 for the square root? How did I get x to the 5th? Could we just take 10 divided by 2 and 6 divided by 2 to get those exponents of 5 and 3? So start thinking about that as a shortcut, or if you like this expanded form, that way works as well. All right, highlight the answer for each. These ones are multiple choice. All right, square root of 4 is just 2. We got an x, we got an x, we got another x. This would work out to 2x to the 3rd. Next one, square root of 16, square root of x squared, square root of y squared. Now, here's an example of one I really don't want to stretch out, right? X to the 100 square root. Can't we just do 100 divided by 2? There's an index of invisible 2 there. 36 divided by 2, and 64 divided by 2. And finally, what's half of? This is a billion. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. 1, 2, 3, 4, 5, 6, 7. Okay, how'd you do on the front?